Kaveri Desai. I'm studying in BSc first sem in Sri Siddheshwara Government First Grade College. My topic is critical phenomenon Andrews isotherm of CO2, critical constants and their determination. Contents: critical phenomenon Andrews isotherm of CO2, continuity state, critical constant, critical temperature, critical pressure and critical volume. Critical phenomenon. The phenomenon associated with the physical changes of a real gas at a specific temperature, pressure and volume is called critical phenomenon or critical state. Example: the physical change of the CO2 from gas to liquid and liquid to gas at a critical constants. Andrews isotherm of CO2. Andrew obtained different types of isotherm by plotting pressure versus volume at different constant temperatures. The following isotherms are explained as follows. This graph explains Andrews isotherm of CO2. Isotherm above 31 degrees Celsius. The isotherm at 25 degrees Celsius is a rectangular hyperbola and approximates to the isotherm of ideal gas. The above 31.1 degrees Celsius isotherm are present. Thus, in the region above the isotherm at 31.1 degrees Celsius, carbon dioxide always exists in the gaseous state. Isotherms below 31 degrees Celsius. The isotherms below 31 degrees Celsius are discontinuous. For example, the isotherm of 21 degrees Celsius consists of three parts. The curve AB. It is a PV curve for gaseous carbon dioxide. Along AB, the volume decreases gradually with the increase of pressure at B. The volume decreases suddenly due to the formation of liquid CO2 having higher density. The horizontal portion BC. Along the horizontal part BC of the isotherm, the liquefaction continues while pressure is held constant. Isotherm at 31 degrees Celsius. Andrews noted that above 31 degrees Celsius there was no possibility of liquefaction of CO2. However, greater the pressure applied, the critical temperature of CO2 is therefore 31 degrees Celsius. The isotherm EFG at this temperature is called the critical isotherm. The EF portion of the critical isotherm represents the PV curve of CO2 gas. A point F, the curve records a twist which is coincident with the appearance of liquid CO2. Here the gas and the liquid have same density and are distinguishable. This point is called the critical point and corresponding pressure is called critical pressure. Critical temperature for permanent gases is very low compared to temporary gases. CO2, Br2. Continuity of state. On joining the ends of the horizontal portion of the various isotherms of CO2, a boundary with the dotted line from a dome-shaped area. Within this area, CO2 is coexisted in the both liquid and gaseous form. The liquid temperature is represented on the top of the dome. Suppose a certain volume of CO2 at a point on isotherm A, B, C, D is heated at a constant volume to a temperature at which the pressure increases to a point lying above the critical volume. On slow cooling at the same pressure, the temperature and volume both decreases to a point at which temperature is 21.5 degrees Celsius, where CO2 exists as a liquid. During this transition from gas to liquid, there has never been more than one phase present at any time. This is called continuity state. Critical constants. The physical parameters such as temperature, pressure and volume associated with. Example: critical temperature, critical volume, critical pressure. Critical temperature. Critical temperature of a gas is defined as that temperature above which it cannot the liquefied, however high the pressure may be, it represented by Tc. Critical temperature of CO2 is 31.1 degrees Celsius. Critical pressure. Critical pressure of a gas is defined as that pressure required to liquefy a gas at critical temperature. It is represented by Pc. The critical pressure of CO2 is 72.9 atmosphere at a critical temperature of 31.1 degrees. Critical volume. The volume occupied by 1 mole of gas at a critical temperature and critical pressure is called critical volume. It is represented by Vc. Example: the critical volume of CO2 is 94.0 mole at 31.1 degrees Celsius and 72.9 atmosphere. Reference books by Chemistry book by Dr. Vinayak M. Nayak. Thank you.